Hi everyone, I'm Jelal Sultanov. I'm machine learning DevOps engineer. I'm also a recent graduate from China University of Petroleum in Beijing, and also I was accepted to University of Passau for AI engineering master's program. So during my bachelor degree, I did several internships as a machine learning engineer, data scientist, and machine learning DevOps engineer. So based on that experience, I would like to talk about machine learning DevOps, what it's about, and how to do it. So today I'm going to talk about the CI/CD and automation of machine learning pipelines. So actually, in the world, there is no unique one standard definition of ML Ops, machine learning DevOps, but however, many of the engineers, scientists try to give it some definition. So as a formal definition, I think MLOps is an engineering discipline that aims to unify ML systems development and ML systems deployment to standardize and streamline continuous delivery of high-performing models into production. So from this definition, we can say that machine learning DevOps is an engineering discipline, and also it's aiming to unify processes of development and deployment. Also, the task of machine learning DevOps is to standardize and optimize the continuous delivery, like iterative process of deployment of machine learning systems to the production. And mainly, when we talk about machine learning DevOps, we are talking about high-performance models. So at large scales, like big scales. Okay, next one. Why MLOps? Until recent times, we had like a small amount of data and a small number of applications running based on those data. So at those times, we didn't have to use machine learning DevOps engineering at all. But now, when we have lots of data and there is a need to utilize those data in order to achieve business goals, KPIs, and so on, we need to like put the machine learning systems into production with automation in mind. So why MLOps? In MLOps, there are several teams involved, starting from bottom to the start. It's starting from business development is where the business objectives are getting defined with KPIs. So in order to start any machine learning project in a company, you would want to first of all, define what you're gonna achieve with machine learning models, systems, what KPI are you looking for. Data engineering. After you get like clear definition of business goals, you need to get the data, like prepare it and feed to machine learning model. And data science. Once we get the data, data scientists start working on building different machine learning models, building like different algorithms in order to train a model. That's what data science does in a picture. IT DevOps. After we get a solution, like after we get a working model, we need to deploy it somewhere, like somewhere on the cloud or something else. And IT and DevOps department need to deploy it and monitor with data scientists. So the life cycle of machine learning system is, as you see, like first of all, you define business goals, then you access, prepare, and process the data for a model. Then you build a ML model with a data scientist, and eventually you deploy it. And machine learning DevOps project is like any other software development. It needs iterative process when it's getting used in a company. So when you deploy a model to the cloud, it's not done. Never. You need to put the whole process into automation so that data gets automatically prepared and cleaned for the model, and the model gets automatically trained based on the data you get from previous step, and model gets automatically deployed into the cloud or somewhere, and all that should be automatically done. So that's a key point of the machine learning DevOps. So yeah, why do pipelines need lifecycle? In addition to what I have said previously, it gives the advantages, I think there are three. Advantage of the machine learning pipeline is that it gives more time for model development. For example, if your data gets automatically cleaned, prepared, and fed to the model, once you have automatically deployed your model to the cloud, you have more time for your data scientists actually to work on the model, actually to work on the mathematical side of the project. Then it gives reduced time to market. As whole process is automated, your time to market gets reduced. Like time to market, it's time that is needed for machine learning DevOps project in order to get to the production. So also the third one is higher confidence in forecast. As your model gets automatically deployed, monitored, and retrained, your loss and accuracy is always at the high. Like you put some triggers, and if that triggers is triggered, your model gets retrained based on the loss, and for that reason we can get higher confidence in forecasts all the time. So major challenges of machine learning DevOps. First one is unrealistic expectations and misleading success metrics. First one is unrealistic expectations, is that many business leaders think that AI is the key to all problems. They think that AI can solve all their problems because they follow trend buzzwords and without knowing any technical background of the problem. So it's important that technical leads always in contact with business leaders, because technical leads are responsible for explaining the technical background, what's feasible, what's not feasible, current technology, and it's important to let the business leaders know what actually possible at current time. Misleading success metrics. Success, like the accuracy of different models, can be measured with one or two or multiple metrics. So it's important for data scientists, machine learning engineers to know which metric to monitor, and it depends. The success of whole project can also depend on this factor. So the second one is lack of communication with IT department. As it's kind of related to first one, where I said it's important to be in contact with business leaders and other teams. So in order to let them know what's possible. Then a lack of iterative deployment. This is where continuous training comes to the continuous integration and continuous deployment, CI, CD, and CT. So in machine learning DevOps, we have continuous training. It's only special for machine learning DevOps. As I said, when you develop some machine learning the DevOps project to the company, it's not the end when you deploy for the first time. After you deploy the first time, you need to iteratively monitor the health status of the model. Is it giving false predictions or positive predictions? I mean, false or right. So yeah, change of data trends. For example, they can be changes in data. For example, imagine stock prices can be affected by news article. So this is out of our control. We can't control those factors. So as soon as our data changes, we need to retrain our model based on those triggers. Like if there is a data drift in our data set, then our pipeline gets automatically retrained. So that's one of the key parts of the pipeline. So next. So conceptual diagram of MLOps. This is the, if you look at this for the first time, it might be confusing, but I will be talking about all the steps separately. Stage 1, experimentation, exploratory data analysis. In machine learning DevOps, as any machine learning project starts, it starts from exploratory data analysis, or EDA. So in this stage, machine learning engineer, data scientists get the data and analyzes it with his tools. And in this stage, we have data analysis, data preparation and validation. Then we train a model, and then validate it, and then export it to the next stage. So often at this stage, most of the projects fail because data cannot meet the requirements of the project, or data is not needed for the project. So in order to start overall project, we need to get the right data with the right parameters. So next one, automated workflows. As you can see, there's an image that has corgis and bread. So imagine following business project that classifies bread. So whenever the user inputs the image of the corgis, the model gives false predictions, because in the previous data set, which was used for the training, it didn't contain any corgis. So for that reason, if there is a change in our incoming data set, we need to automatically retrain it. So what happens next if the model does not get trained? So screams of the managers and orders of like repairing it until tomorrow. And machine learning developers, like engineers, don't have any other options because they don't have any new data set. So here is clear example of where MLOps is used. So whenever there is a data drift, models should be updated automatically, because on the other hand, nobody forbids users upload images of corgis. So yeah, automated ML workflow pipeline. So yeah, this is where we have a feature engineering pipeline. We connect to raw data. It can be streaming data, batch data, or cloud data, of course labeled, and we extract the data, not all of the data set we need. Then we transfer and clean it and get the features out of it. Usually the data set we have can't meet the requirements. So in order to use the data set we have, we can use feature engineering, for the tabular data we can use x, square root of x, and so on. The next one, serving and monitoring, CI, CD, CT. CI, CD component that deploys production-ready models. Here, whenever you upload the model, you can also put test-driven development into the pipeline. So your model gets checked and your data also gets checked. At the end of the pipeline, your model gets deployed. So next one, MLOps project initiation is that all project starts with the problem analysis, defining goal, as I already talked about it, then designs architecture and technologies to be used. This is other person who does it. Then data scientists derive ML problem from business goal, he defines, is it classification problem or regression problem, and so on. Understand and require data to solve the problem. It is data science and data engineer, how to get it, where to get it, the data. Then we connect to raw data for initial data analysis and distribution analysis. This is done by data scientist and data engineer. So next one, software for automation of the pipeline mostly use a clear ML, Kubeflow, and for experimentation usually is used MLflow, again clear ML and Kubeflow, and serving and deploying for model, core, and bento ML. Yeah. So the team, talking about the ML engineer, ML ops engineer, it's kind of the person that has different skills. That, for example, has the backend engineer, DevOps engineer. It's like mix of those engineers, and in total we have ML ops engineer who has different skills in order to orchestrate that pipeline. So yeah, thank you.